Good morning, students. How are you today? Thank you. Now we are going to start today about force between two point charge particles when they are placed in multiple dielectric field. So it is based on Coulomb's law. Before that, we have seen about Coulombic force between two charged particles if they are placed in air and also in uniform dielectric material. Like you can see here, if Q1 and Q2 2-point charges placed at distance r, and that is epsilon r will be 1, I mean this air. So you know very well that if force F can be written like 1 by 4 pi epsilon naught epsilon r q1 q2 r square, that is magnitude of force, and we can write 4 pi epsilon naught q1 q2 by r square. This is, we can suppose, equation 1. Now the charged particles are placed in uniform dielectric material of constant K. Now we have to find force between Q1 and Q2. That force will be F1 and 1 by 4 pi epsilon naught epsilon r. We can put the value of K and Q1 Q2 by r square. This is equation 2. Now see, if distance fixed, but once material changes, that is dielectric material changes, so force changed by 1 by K times, and charges also remains constant here. So from 1 and 2 we can write, from 1 and 2 we can write F directly proportional to 1 by K, where K is dielectric constant. Once R and charges are constant, so F increases, K decreases, K increases, F decreases. On this basis, we can calculate force between two charged particles when they are placed in multiple dielectric field. So here our question arises here, how we can calculate force between two charged particles when they are placed in multiple dielectric constant. Like see, if there like two charges here Q1 and this is Q2, and if they are placed between two medium, one medium is taken like this is medium of dielectric constant K, and this is air, and also this is air. So how we can calculate force between Q1 and Q2? Q1 and Q2, you have to discuss about this today. So this can be done with the help of, we can calculate effective distance between Q1 and Q2 once there is no dielectric, only air. So suppose that if this one and this one, we can compare F directly 1 by K. If I put here like this equivalent Q1 and Q2 here, and if I put distance R effective distance, and that is, suppose that is free space, or you can put air. Now this force can be balanced with this force once we increase distance a bit. So this distance can increase, so it can neutralize the effect of K here, and we can here find R effective to equate this equation 1 and 2. So on this basis we can write here to calculate R effective like 1 by 4 pi epsilon naught and Q1 Q2 by R square K, that is only R K R square is equal to Q1 Q2 by 4 pi epsilon naught R effective square. Now see, we can cancel this one cancel. So what we got from here, K R square is equal to R effective square, and that implies R effective we can write root K R, root K R. We can write here root K R. So here it would be root K R, and that is the effective distance between A and Q1 and Q2 charge. R effective root K R. If we put the value of R here, and then this force will be equal to this force. Now see, question here we have to calculate force between Q1 and Q2. One dielectric material of thickness T is placed here. So see, on this basis we got R effective. So here we can see R effective we got, that is root K and R, where R is the distance between two charged particles and K is a dielectric constant. Now come on the question. What is question? This one Q1 and this one Q2. Now a dielectric material is placed between these two charged particles of thickness T. And dielectric constant K. Now distance, this one is R. So we have to calculate force between these two charged particles Q1 and Q2. You got it? Now see, we got the expression R effective, isn't it? Now see here R. Now we can apply this concept here. So this can be written like this. This can be written like this: Q1 and Q2. And effective distance, calculate R effective. That can be written like, that is, you can write here, that is, you can put first, instead of this dielectric, you can put root K, that is T, plus this R minus T, because this distance subtracted, so R minus T, and that would be your effective distance on the basis of this. Now we got here R effective, we got, that is R effective distance root KT, or you can write here R minus T plus root KT. This is the value of R effective. And once R effective there, so we can find force easily, and that force is K, 1 by 4 pi epsilon naught and epsilon R, that is Q1 Q2 by R square, and that called R effective square. So now we can write this one 1 by 4 pi epsilon naught Q1 Q2. R effective we can write here, that is this we can write otherwise R minus T plus root k t square. So this is the force between two charged particles placed in multiple dielectric materials. If it is AR and this is also AR and this is the what dielectric materials of thickness T. So this if in questions T is given, K is given and R is given, we can find force with using this expression, that is formula. So this one is very important to get your result. This is very important to find force between two charged particles once they are placed in multiple dielectric materials. So you got this concept, and this is the based on also Coulomb's law. Any doubt? Nidesh, any doubt? Tell me.
No, sir.
No. So thank you so much for this, and you can apply this one. Thank you.